There might still be a few more people turning up. What I've got here on the screen, though, that you should be able to see is just a few lists here. So the first, and a few little questions just to go with it. So I thought with tonight, I don't want to go too far into dictionaries. I'm not sure whereabouts Eva is up to in the tutorials or in the lectures, and I don't want to get too far ahead. But I also don't want to get behind. So I am going to do some stuff on dictionaries tonight, looking over the workshop 1, the dictionary there. But I thought with nested lists, just a fairly straightforward activity here, and let you think about it for a bit. And you'll see in here I've actually got multiple lists within lists. So it's not just a list within a list. And this second one here, I've got a list within a list within a list within a list. And so there's multiple lists within lists there. And so the questions were, how do you access the X element of this list? So in order to print it out, what would I type in following that N list 1 to access that X element? And same with the other ones as well. And also just what is, I'll explain the first one, what will list 3 look like, and I've probably already given the answer down the bottom there, so we'll just have to finish that and run this a whole lot. There we go, it's gone. So I've got 5 questions here. So the first one there is, what will list 3 actually look like? So at the top here, list 1 is a list with 2 sublists in it. And so the first sublist contains the elements 5, 6, and 7. So that is the 0 index of that first sublist, the first index of the first sublist, the second index of the first sublist. And the second sublist has 8, 9, 10 in it. List 2 has also 2 sublists. The first one has 1, 2, and 3, and then the second one has some strings, so A, B, and C. Not doing any calculations or additions with the things inside those sublists, but I have made a new list. So list 3 here is list 1 plus list 2. And if you remember from way back at the start, you can add lists together. So if I just quickly run it down here, n equals, I'll type it down the bottom there, 1, 2, 3. So this is just a very straightforward list. M equals 4, 5, 6. And P equals M plus N. What is P? 4, 5, 6, 1, 2, 3. So it just joins them together into one big long list. So what I'm asking here, and just take a minute or two just to think about it, and then if someone wants to type the answer up down the bottom, that's fine. If not, I'll just go ahead and kind of explain it. But what is list 3 going to look like after I've joined these two things together here? Yeah, both those look right. So yeah, it'll just join them. It'll join those elements together. So this will become the first element of the new list. This sublist here will become the second element. This one will be the third element. This one will be the fourth element. And you can just test that by typing down the bottom here. Print now list, or I just type list 3 actually. List 3. And so we've got 5, 6, 7, 8, 9, 10. 1, 2, 3, and then ABC at the end. So it really just does combine those lists together. So that's pretty straightforward. But then we've got accessing those sub-elements in there. So you want to kind of get all the way down to not what I call a kind of a leaf, if we think of it as a tree. So if this is the entire tree, and then this is one branch in the tree, then these little elements here are going to be leaves to the tree. So how do we access those? So for example, if I wanted to access the 7, or maybe I don't know what it is, I want to find out what the second index is of the 0, or the first element in the whole list, I would do list 1. And I'm just typing down the bottom here. Might make my screen size a little bit bigger. So you should be able to see this down here. List 1, 0. Now that's going to show me that first sub-element, or that sub-list. And then list 1, sorry, list 1, 0. Then to access the 0 element of that, it would just be 0. But I want to actually access the 7, so that would be 2, which shows me 7. Now we're not limited to just 2 sublists. We can have multiple lists, which is not something that, well, you can, like I was saying last on Tuesday, that in C#, C++, I think JavaScript as well, you can have 2-dimensional arrays. Essentially in Python you can have unlimited dimensions of arrays. I can't think what you would use that many different dimensions for if you were trying to make some kind of multi-dimensional array, but you can store lists within lists within lists within lists, etc. There's probably some kind of limit as to how deep you can go, but we're unlikely to find it in our exercises. So the first question here is, how do I access the X element of the list? Actually, they're pretty much all the same. All the questions are the same, they're just accessing different. So the X is in this part of the sublist. The 10 is in this one here, and the 2 is in this one here, and the C is in this one here. So have a go and see if you can figure out how to actually access those. Some of them will have more indexes on the end of them. Let's just see. Now if we do this, it's going to give an error, and it will give an error like that. Now this is how you would, in say C# or a language that does support 2D arrays, this is how you would access something in a 2D array. So 0 that way, and then 2 going down in like a little grid. In Python, we have to access everything individually. So if we did this, it's just more than likely going to throw an error. It's kind of spitting everything. Oops, I ran the program. I didn't actually. But, oops, hold on. List 0 to 0. There we go. Enter. Gives an error. So we can't do that, but we can do this. So if we go list 0 to 0. So all those square brackets around each one, and attribute not found. So that's not the right one there. And I'll just try the next one, list 1. Oh, hold on, I'll try that again. 0. I put the wrong variable name in. Trying to access part of the object that doesn't exist. So let's see. List 1, 0. I'm using the wrong thing, sorry. My mistake. It's end list. Yeah. So that gives the Y. So for the X is actually, if we look at this here, I can't hear. Is the volume back? Okay, cool. So let's just stop at the X for a bit, because we need to figure out where it is. It's not quite the deepest in our sublists. So the deepest ones are these ones here. But if we look at, we'll just build it up from bit by bit. So n list 1, 0 gives us this here. So that's the 0 index, and there's kind of a few lists in here. There's actually a sublist there, and then another one there, or the two sublists inside that list, which is inside this list. So to access the X, it's going to be n list 1, 0, and then it's going to be 1, I think. Yeah. Because if we look at this first element is actually another list, which contains two more lists inside that. And that's a 0 index. And then the first index of this is the X. The 2 is the Y. The 0 is the Z. The reason this one worked was because it was accessing the 0 index of that Y string, which was Y. But if we put in a 1 there, it wouldn't be Z. It would actually be, it would give an error because there's nothing else in that string. So this was actually accessing an index of the string. So this here is 0, 1, and this here is at element 0, and that is at 1 there. So that's how we get that one there. For the second one, for the 10, let's check that, n list 1. It's not going to be 1, 1, 0. It's actually, I'll just bring up n list 1. If we look at this, the first element of the entire thing is that complete sublist there. That's actually the whole first element. If we look at how it's broken up with these commas and where this bracket starts and where this bracket ends, that's actually the whole first element in the array. So to access the 10, it's n list 1. Right. No mistake, n list 1, 1. And there's the 10 there. So it's really looking at where these brackets are matching up, where they're opening and closing, and what's the first element. So that's the whole list, of course. And then we've got that there. I might just quickly open Eclipse and see. I might have to put on my whole screen because I think that Eclipse and even Notepad++ will do bracket matching, which is really, really useful. Yeah, okay, it does. And I won't worry about trying to do it in Eclipse because it's really difficult to make my font size bigger. But I can do it in Notepad++. So what I'm going to do is I'm just going to modify the screen sharing so that you can actually see this. Now you should be able to see hopefully my whole screen with Notepad++ there. Can that be seen? Or do you see the Massey website? Okay, so if we look at this here, you can see in Notepad++ that it's actually highlighted the opening and closing bracket for me. So this is really handy. It would be really useful if JES did something like this, but it doesn't. So if I click on this bracket here, you can see that it actually closes there, and that's that entire element. So that's the whole first element of the list. So this is the list. This one here is that first element of the list. And then inside there, the first element of that sublist is actually another sublist. And then the first element of that one is another sublist. And there's also two sublists in that very inner one. So if we go back to here, to access, we'll just put this in, to access the X, we're going to access the first index, which is out there, so 0. And then we're going to access the the 0 index there. Then we're going to access the first index here, because the 0 index of that one is that whole sublist there. So that should print out X then. And then this one here was just 1, because the first index of the highest level sublist, or the highest level thing, is this is 0, sorry, is this whole bit here. And then the first index is that one there. Now to access the 2, this is a bit deeper in. So we're going to need to get that 0 bit out. We know that that contains the 2. So I'll just check that down there, n list 0, n list 1, 0. So that contains the 2 there. And then if we put in, we'll check again, n list 0, 0. I keep forgetting that 1. I don't know why I put it there. Then we've still got that, so we know that that's there. N list 0, 0. And then we want the 0 index of this one. So n list 1, 0, 0, 0, which gives us that. And then it's going to be a 1 on the end. So it will be 0, 1, like that. So that's how that bit works. Then finally, the C element. The C element is pretty much the same as this one here, except when we get to that second deepest one, instead of picking the 0 index, we actually want to pick the first one, which is going to have the ABC string in it, which is going to be that, and then that will be 2, because that's the second index of that there. So if I load this program, it should print out, well, I'm not sure what just happened then. Am I back? Am I back? Something just crashed on me. I'll just share my screen. I'll go back to sharing the JES window. Okay, I'm not sure how much just got cut out then, but I was just saying that to access the C element, just crashed on me again. So hopefully we'll be all good this time. It may just be my monitor. I may have to reach around the back and just plug it in. It's been playing up a bit today. What I was saying was that to access the C element of here, it's very much the same as accessing the 2. It's in that same sublist. Oh, I can't see screen, sorry. Let's see, share screen. It's in that same sublist, this one up here, except it's the first index of that sublist and then the second index of that list. So that's why I've got the 1 there and the 2 in there. So when I load this program, it prints out X10 to C. So those are all working in there. Now, I'd like to go on to dictionaries. Unless anyone has any questions, I haven't seen any of the lecture notes have any more depth than just 2 elements. So you probably only need to be able to follow up to 2 elements, but there may be a question in the exam, there may be a question coming up in an assignment or a test or something that does ask about 3 elements. So it is worthwhile just trialing some of these, even just making up your own sublist. You've got to make sure all the brackets match up, and then seeing if you can access them, just to make sure that, yep, I get how these work. I can store multiple lists within lists, within lists, within lists, etc. Oops. All right, we'll move on to the dictionary, which is this one here. Now, the other day I created a few very bad dictionaries, but this is a pretty good example, this one here. So just looking at it from the start, I'll just load this program. I've left all my stuff down the bottom. We'll just comment that out for now. Okay. So what we've got at the top here is the dictionary. So I'll just create a dictionary down the bottom here as well that I can use as an example. I'm going to call it D equals an empty dictionary. So now I've got an empty dictionary. If I type D, it shows me my empty dictionary. The way that you assign things in a dictionary is by just telling it that it equals something. So you give it a key and then assign it a value, very much like a variable. Unlike a list where you want to append something to a list, with a dictionary you can just give it a key and say it's now equal to this. So in my dictionary, I might give a key called fruit. And it might be best if I just do it with lowercase. And because it's a string as a key, I need to put quotations around it. I can't just put it as a variable. If a variable holds a string, I can just type the variable name in there. So what I'm going to do is I'm going to create a key called fruit, and it's going to be an empty list. Okay, so this key is going to be assigned a value. The value at the moment is an empty list. So now if I type D fruit, it shows me an empty list. So that's what's associated with fruit. If I type in here D fruit, oops, it shows me the empty list. But I can now use the list, and I can append things to this list. So I can append an orange. I can append an apple. I don't know why I always use fruit as an example. Oops. Bananas. It should have just been banana. Put in pear and peach. Now if I look up fruit, just by that index, so I've got my key value, my key here, and it shows me all of the the value associated with that key. Now the value is just a list, but in the list is all the fruit that I've listed there. Now I could type up another key here, meat, equals empty list, and then we'll append some stuff to that. dmeat.append. And the only reason I can use append here is because I've actually said dmeat or dfruit is that the value is an empty list. If it was just a string, I couldn't append anything to it. If it was an integer, I couldn't append anything to it. But because it's a list, I can append something to it. So I will append, let's see, chicken and beef, lamb, pork. Okay, so now if I type in D, you can see the entire dictionary. We've got our key, which is fruit, and we've got our meat, which is chicken. We've got our meat, which is the list here. We've got our fruit, which is all of this fruit in a list. We've got our meat, which is all of this meat in a list. So I've got things, and I'm associating them by a key, which could be a number, but in this case it's more meaningful for me to actually use a value. So I know that what's going to be in that, or what's associated with that key, is an array which contains all of my meat products. And in fruit, it's going to contain, it's an array, or a list, sorry, containing all of my fruit products. And I can do other things with the array. So with the dictionary. So if I do d.items, it's going to actually, if we look at this here, and it's important to understand this part here because of what it returns. d.items, you'll see it actually returns a list with two tuples in it. The first one, the first element in the tuple is the key. The second element in the tuple is the value. And all of that is stored in a list. So the first tuple in that list is the fruit and fruit's key value pair. And the second one is the meat and the meat's key value pair. Now if I type d.keys, that's going to just give me back an iterable item. It's not actually a list, but it contains fruit and meat. If I do d.values, And so these here, these items, keys, and values are all methods associated with a dictionary. It's going to give me back the values. So having said that, at the top here, if we go through this this program that's been created for the sports teams, Super 15 is just a dictionary. And the keys in here, the best key to use would be the team name. As long as you're probably looking for something unique, if you've used databases before, something like a primary key, where you only want one value as a key. You don't want multiple different keys that could be a bit ambiguous. Like we couldn't use country as the key because we've got multiple values here. In order to use country as the key, we'd have to store multiple lists, so each team associated with that country. It could be done, but it's not as easy to find teams by names. It would be easier to find teams by country though. So there's a trade-off, and you need to decide, well, what am I actually going to be searching for the most? What do I want to associate things with here that's going to make it easier for me to use? So we've got Super 15, and the Bulls key is associated with an array, and that array has in order the country, the number of games they've played, and the current score that they're at. Then the cheaters, the country, the number of games they played, the score that they're currently at. So fairly straightforward. And if I just print out here, oops, we'll go down the bottom. If I do Super 15, it's going to print that entire dictionary out. But say I do Super 15 and I type in Lions here. It's only going to return the Lions results. So they're from South Africa, and they played 9 games and they scored 16 points. If I do Super 15.keys, it's going to return all the team names. Super 15 dot values, it's going to return all the values, and then Super 15 dot items returns the key values pair, which is a bit longer. Now this function here, definition add game, it accepts a team and a score. Now if I was writing, I'd probably also make it accept the dictionary. It's a mutable value, so it doesn't matter, but I don't like things to be global, but it's not a problem in this case here. So team, score, if team is in Super 15, so we can actually look and see, is that team one of the keys in the Super 15 database? And if it is, then we're going to modify it, and we're going to add that there. Now there's something wrong with this, and I'll just demonstrate it. So at the moment, we'll look at the Chiefs down the bottom. So Super 15 Chiefs, spell it right will help. You can see their New Zealand team, they played 9 games and they've got 24 points. So if I go add game, Chiefs, we'll give them another 6 points, which should bring it up to 30. Hopefully that worked. Let's bring it up. It now says that they played 9 games, they got 30 points. But there is a slight problem with this here, and that it should also increase the number of games that they've played, if I'm understanding it right. So Super Team 1, which is the number of games that they played, that's the first element in that. X equals Super, also just plus equals 1. So let's load that program. Type this in again, add game Chief 6, and so now it's increased to 10 and 30. If I do it again, it's now gone up to 11 games and 36. So that was just something that I noticed in the program there. It doesn't, it's not going to make the program crash, but in terms of actually keeping track of things, it's a value that's missed out. And so you might want to add that in there, just understand how that's actually working. So if we go through this just again, just to make sure that we clarify what's going on here. So the add game function accepts a team. In this case, I said Chiefs team, and I gave it a score of 6. If team is in Super 15. Now I can I think I can just type something like this down here. Chiefs in Super 15. And it should give me, yeah, a 1 or a 0. So I can check, well, 1 is true, with 0 is false. But if I type in Chiefs in Super 15, it gives me a 0. Now, if I type in SA in Super 15, it gives me a 0, because even though it's in one of the values, when I do this, it's looking for it in the keys. Kind of like doing this. It's pretty much the same. Okay, so when I just do this here, it's working. Now, if I was to change this and say SA in Super 15 dot values, it still gives me a 0, because none of these are just set to SA. And I'll just quickly modify this here. I'll just change the sharks. They can just be SA. They don't have a list associated with them anymore. They're just SA. So that's their hometown. They don't have score or anything up there. They're just not like the others. Now if I do this here, let's say SA in Super 15 dot values, it's going to look through all of those values and see if any of them match SA. Type the wrong thing in. And there's a 1, okay, because this one does match SA. Even though SA is in the other, what do you call it, the other lists, it's trying to match the whole list, not the individual string. But because I've got this here, it does. If I get rid of it and change it and put it back into the list, which is what I had before, it will not match it anymore. So there's a few different list operations to be aware of, especially because when you're working with dictionaries, inevitably you're going to be wanting to store more than one value. So you might want to have like fruit and then a whole list of fruit associated with it, because you wouldn't just have fruit and apple, because there's more than one type of fruit. So you would want to have a whole lot of things associated with it. Sometimes you will only want one value associated with a key. So it could be, the key might be a surname, first name combination. The value might be a phone number. And that's one of the examples for Module 2, which we'll look at next Tuesday and Thursday. I think it says Workshop 2, which has the phone book examples in there. Now if we go down to the country table, this is pretty much the same as it was for the list, because what we need to do is iterate over all of the different key value pairs in the dictionary, and then just store all the ones that match the country in a temporary list. In fact, if I just bring up the nested lists one, I'll just show you. So this is it for the, oh, it's crashed again. I'm not sure why it keeps crashing tonight. Is anyone else getting kicked out, or is it just me? It kind of kicks me out and then I come back in. Is my voice working? Alright, I'm not sure what the issue is here. It keeps on kicking me out. Can you hear me? I'm not actually sharing my screen at the moment. Okay. I'll try and get through this last bit here and then we'll finish up. Just this bit on the country table, and I won't worry about going over the one with lists. I'll just go over the one with the dictionary. I'll just see if I can get it to share without crashing. I'll just share my entire screen. That might be the problem. So you should be able to see JES now without an issue, hopefully. Alright, so country table, country. So country table accepts a country, so it could be NZ, SA, it could be China, it could be Japan, it could be anything, but it's only going to match them if they're actually in the dictionary as values. So we create an empty temporary list, it's just empty. It's going to cease to exist once this function is finished. And here's the bit that works really well with dictionaries. So for key value, and this is actually getting two things out of here, because super15.items, if I type it in down the bottom, if you remember, returns the list with tuples in it. And so we've got down here the first tuple in there. This is the first element in it, and then this is the second one. So the second one is the list, the first one is the key. So if value 0, so it's saying, okay, we'll assign the first element in the tuple to the variable name key, assign the second element in the tuple to the variable name value, and it iterates over each one of these. So the first time it uses those two, the second time it uses those two, the third time it uses those two, etc. And if value 0 is equal to the country, so value 0, which is this one here, and this one here, and this one here for each iteration, if that is equal to the country that I put in, then we're going to append value 2, which is the score, and the key, which is the name of the team. So we don't need to know the name of the country, because we assume that we know that because we just typed it in. We don't really need to know the number of games, but we could add that in. And then we print a temporary list. Now, this has removed the sort and reverse. I'm not sure why. I can put that in and it should work. So let's just test it. So we've got NZ, AUS. I'll just hash these out so we'll just get SAs up. Table for the teams from South Australia: Cheetahs, Bulls, Sharks and Lions, and there is the resulting temp list. But if I get rid of these here, it should show them in reduced order or descending order. So 20 Sharks, and then the Bulls, and then 16, 14 and 10. If there's a tie on the first one, it goes to the second one. So in this case, Sharks is first, then Bulls. So highest to lowest. And that prints that out. And then this one here for teams, table for the teams from there. This one doesn't have the, what would you call it, score in there. So we could put that in, entry 0 plus tab. So now if I run it, whoops, I've got to convert that to a string. And then that puts that in like that there. I'm not sure, there is a few things missing from this. So we will finish up there because it keeps on kind of crashing on me. I'm not sure what the issue is. And that's kind of that entire workshop really anyway. So next week I want to take a look at workshop 2. And workshop 2 is, I think you should be able to see my whole screen. Workshop 2 is this one here. And there's some really good questions down the bottom. Creating a phone book program, so using a dictionary to create a phone book program. And they should be able to search for by an entry. It's very similar to the sports one that we just did, the search. A linear search is probably fine for that one there. Creating a movie information program. And this is a really good one. I've probably still got my work from last year on this one. I think we had to do this as an assignment last year. So I've got that in there. We can have a look at solutions for that. And there's also solutions provided if you want to get ahead and take a look at those. And there's some really good questions here guiding questions for getting started with a programming task. And these are things that I've talked about before as well. So what tasks do we need the program to do? What input does it need? What output does it need? Building it up bit by bit, thinking about the data types that you need to work with. And there's a whole lot of really good questions down there. So this workshop 2 is starting to move into some more complex, larger programs. And it looks like you haven't had to submit any tutorials yet. What about assignments? Have you had to submit assignments? Or has it just been the exams? I'll have to see if I can have a look at the assignment and see if there's it doesn't show for me. No, it doesn't show up for me yet, but when I get access to that, I'll take a look at it and see if there's anything that may be difficult in there that I can provide some different examples on how to get them working without actually giving away the answer in the assignment. Sorry for the mess with the constant cutting in and out for that one. We'll finish up now, unless anyone has any questions about anything. Kind of got split up a bit there, and my train of thought kept getting thrown every time I got cut off. All right, great. Okay, I will see you next Tuesday.